Okay. What page? 157. The only difference is, so far everything we've done has been in a line. It's been one dimension. It's been just a length. Okay? 150 inches. How many centimeters is that? Okay? 3.2 miles. How many inches is that? It's all linear. Now we're looking at squares and cubic units. That's volume. All right? So, let's look at this guy. Calculate the area, and area is always in square units, right? And think of this. If it's a rectangle, it's length times width. If it's meters times meters, remember exponents. You multiply with the same base, add the exponents. That's where the square comes from. What's the area of this in square meters? Well, our formula, hopefully we all know. I'm sure it's on your formula sheet somewhere if you don't. But for a rectangle, even a special rectangle like a square, we just take the two dimensions, multiply them together. What's 1 meter times 1 meter? 1 meter squared. Okay, piece of cake. So I want to know how many centimeters that is. I know there's 100 centimeters in a meter. So is this 100 square centimeters? Heard a yes. I saw a couple shakes no. You might think it is. Well, again, who's good in psychology? Why is he asking the question? Must not be true. It's not. And the reason is there's two of them here. Okay, let's look at it this way. What's a meter? I know that's 100 centimeters. There's 100 centimeters in a meter. Okay, that's on your formula sheet. This is a meter stick. Look at the end. It says 100. All right. And, well, this is also a meter. So if I want this in square centimeters, length times width, what's 100 times 100? How many zeros do I have? All right. That says 10,000. So which is it? Could it possibly be 100 and 10,000 at the same time? No. One of them's right, one of them's wrong. This one is right. Okay? This one, you can't do that. There's another way to teach this, but I'm not going to confuse you. I'm just going to teach it one way, okay? But because there's a square, you need to do the conversion twice. Times that by 100, times it by 100 again. Well, that's just what we did here. All right? This is what we need to remember. And if you just remember this, you'll be fine and you'll get them right every time. Okay? Before multiplying dimensions, and I don't care if it's area or volume, convert first. Okay? Flag, flag, highlight. Ooh, how about green? If you just remember that, you won't make a mistake when it comes to the second or third dimension. Got this, Mac? I didn't see you copy it down. Okay, when I'm highlighting something, it's important. Okay, you probably want to copy this down. Guys, this book here, it's just fill in the blanks, and some people still are too lazy to do that. It just boggles my mind. Okay? Now, let's make the same box millimeters. What do I want to do first before I multiply my dimensions? Yeah, what did I just write? Convert first before you multiply. Okay? So 1 meter. Okay, if we don't know, then we're going to convert this to centimeters. Which do I want on the top? Which do I want on the bottom? Okay, and I know this is on your formula sheet. 1 meter is 100 centimeters. I want to cancel meters. That goes down there. Okay? And yes, we know this. 1 meter is 100 centimeters. Okay? But I want this in millimeters. So that's going to give me centimeters. And I know 1 centimeter is 10 millimeters. Which one do I want on the top? Which one do I want on the bottom? I want to cancel centimeters. 1 centimeter is 10 millimeters. Okay? All the numbers on the top multiply. All the ones on the bottom divide. Okay? So I got 100 times 10, which is 1,000 millimeters in 1 meter. Okay? And this is also a meter. That's 1,000. It's converted into the units I want. Then I multiply. What's 1,000 thousandths? 1, count the zeros. 1, 2, 3, 4, 5, 6. Yeah, 1,000 thousand. Wouldn't you want to have $1,000? That's $1 million. Okay? Does that seem kind of like a lot?
Yeah.
Let's just think about this a sec. That's 1 meter squared. Okay? That's this size right there. There's a meter by a meter. This box, it's like half of this whiteboard. If I said to you, come up here and count all the square millimeters in this space, if you counted 1 per second, it would take you 11.5 days. Round the clock, 24 hours a day. That sounds like a good project, doesn't it? Okay, isn't that amazing? Just from half this whiteboard, square millimeters, there's 1 million. Okay. If I don't have 1 by 1, same process. In meters squared, that's easy, right? Length times width, 8 meters squared. If I want this in centimeters, do I times this by 100? Calvin? Do I times this by 100 if I want this in centimeters squared? Or do I do something first? I convert these first. That's 400 centimeters. There's 100 centimeters in a meter. Okay, I got 4 of them. 200. 8. How many zeros do I have? Okay. Convert first. If I want that in millimeters. Okay. That's 4,000 by 2,000. I just did that conversion. And that's a bad 8. Lots of zeros. That's still a bad 8. Whatever. Okay. 8 million millimeters squared. Okay. Don't worry about all this stuff. Volume. Same procedure. You just have one more dimension. What's your formula for volume of a, what do I call this shape now? Don't call it a cube. A rectangular prism. Sweet. It's length times width times height. But remember, on your formula sheet it doesn't say that. It says base area, which is length times width times height. Okay? Either way is going to work, guys. All you do is take the 3 numbers, multiply them together, because it doesn't matter where the base is. Okay? I can rotate this thing on this side. Now I got a new base. I can flip the top to the bottom. Now I got a new base. What's 1 times 1 times 1? 1 meter. When you multiply with the same base, add your exponents. We know volumes cubed. That's what we trained you to do in grade 8. Okay? Now we're kind of telling you why. You got 3 dimensions there. All right. Is this the same as 100 centimeters cubed, Bryce? No. What do I want to do first, guys? Convert first. 1 meter is 100 centimeters. 100 centimeters. 100 centimeters. Now when you go length times width times height, how many zeros do I have? Yeah. A cubic meter is 1,000,000 cc's, or cubic centimeters. Okay? Same thing. I don't care what the dimensions are. Okay? Convert first. Is this going to be any different if I'm talking, what's the word for that US stuff? Imperial. Okay? No, it's not. This is 1 square foot. That's how much area is in this box. Is that the same as 12 square inches? No. What do I want to do first, Tyrell? Convert first. How many inches in a foot, guys? 12 inches in a foot. That's on your formula sheet. What's 12 times 12? 144 square inches. Okay? Feet. That's fine. 15 square feet. Okay? Whoop. All right. Do I want to try to convert this square footage? Or do I want to do something first if I want it in inches squared? Convert first. 5 feet. Most of us can probably do this in our head. How many inches is that? Okay, someone says 60. How do we do that? Well, if you see that, great. And if you don't, 1 foot is 12 inches. Same procedure. Feet cancels out. Now it's in inches. 5 times 12 is 60 inches. 3 feet, 36 inches. Okay, now in inches squared, length times width. What's 60 times 36? That's too big for my head. 2160. Okay? Now, that's the way we're going to teach it. As long as you remember to convert first, you're going to be fine. Is there a way to do this from here to here? Yeah, there is. And for the top, 5 or 6 kids, if you're curious, how do I do that? Okay, I'll just say it quickly. But for the rest of us, as long as you do this first, you won't need to know this. Okay? Because it's squared, we just need to do it twice. This is the only one I'm going to write like this, okay? I know 1 foot is 12 inches, but I need to do that twice. I need to square this in order for this to work. And what's 15 times 12 times 12? What's 15 times 144? It is, in fact, 2160, okay? If you're doing volume, you need to do it 3 times. So you can do it that way, but like I said, to teach a whole class, that's all we need to know. Okay? Convert first. Let's look at this one. Volume. Okay? In cubic feet, just multiply the 3 numbers together. Does it matter what order you do them in? No. Okay? 3 times 4 is 12 times 5 is 60 cubic feet. Okay? Feet cubed. If I want to put that in inches, Bailey, what do? If I want to put this, if I want to know how many cubic inches are in this box, what do I do first? Convert. 5 feet is how many inches? 1 foot is 12 inches. What's 5 times 12? 60. What's 3 times 12? 36. What's 4 times 12? 48. So the volume is base area times height, or length times width times height. Because, hey, what's the base? There's nothing there. Doesn't matter. Let's call that the base and call that the height. Turn your head like that. Okay? Doesn't matter what order you do them in. 36 times 48 times 60, inches times inches times inches is inches cubed. And what number is that? 103,680 cubic inches. Okay? So I don't care what shape, what units, if it's area or volume, convert the dimension first, and we shouldn't have a problem. Okay? That's all child's play. Now let's look at this guy. Page 161. Question? Complaining? Typical. Huh? Typical. 15-year-olds. Okay. Practical question. I'm buying something. It's in Europe. Okay? It's in meters. I want to know if it's the size I need, because I'm an American, and it's in feet. Okay? Which one is bigger? Can you tell by looking at those boxes which one's bigger? Who said absolutely?
Absolutely not.
Okay, absolutely not. No, because this one's apples and this one's oranges. How do you compare apples and oranges? You can't. You have to make them both apples or you have to make them both oranges. What's he talking about? He's going off on fruit. Okay? Either you have to convert this one to feet so that you can compare, okay? Or you convert this one to meters so that you can compare. Now they're both in the same units. You can calculate both the volumes and see which one's bigger. Does that make sense? Okay. If it doesn't, well, memorize it. This is what you got to do if you want the mark. Now, I want to know which one's greater. Now, you can't just go, I don't know, let's pick that one. You got a 50-50 chance. This is grade 10. You're not going to get any marks for that. By how much? Okay? Which means you have to find the difference between the two. Now, where do we want to convert? What do I want to convert this in to compare them? Be careful. Read the question. Because they want the difference in cubic centimeters. So that's what you want to convert them in. Okay? Both of them. Do that right away. It'll be less work down the road. Why would I make this one feet and then have to convert it all back to centimeters again? Okay? Let's just make them both centimeters first. Does that make sense? Okay? Hope so. All right. So let's call this one box A. Okay? The metric one. I want to convert this one to cubic centimeters. So do I want to multiply those three dimensions in meters, or do I want to do something first? Jolene? Convert first. Okay, so 0.8 meters. Some of you guys already know this, but if you don't, I want to convert that to centimeters. Okay? I want to cancel out meters. So I put meters on the bottom. I know there's 100 centimeters in 1 meter. That's on my formula sheet. How many centimeters is that? Okay, units cancel out. I'm in centimeters. What's 0.8 times 100? 80 centimeters. Okay? I also need to convert 0.6 meters. And hey, that's kind of nice. The third dimension's the same. So I only need 2 conversions here. Do I want to write this one out again, or can I just look at the other conversion? Because it's the same thing, right? What did I do with this 0.8 meters? Times it by 100 centimeters. Can I do that here too? Yeah. So if I times that by 100 centimeters, I know this is going to be in centimeters. So that's 60 centimeters. And that's my third dimension too. All right? So the volume of box A, okay, is length times width times height. So 80 by 60 by 60, and that is 288,000. What's the unit? Centimeters cubed. Okay? Half done. Almost. Still got to take the difference. Okay. The second guy, let's use a cool green. That's in feet. That's box B. And let me do that in green. Okay. So for box B, I want to find the volume of that in cubic centimeters. I need to convert each one of these feet into centimeters. Let's start with 2.5 feet. Okay? Hey, this might be a question on your quiz in about 10 minutes. How many centimeters is that? Do you have a feet to a centimeter conversion on your formula sheet? You do. But let's pretend I didn't know that. 1 foot is 30.48 centimeters. Okay? I don't know that. But I do know, okay, 1 foot is 12 inches, and I do know 1 inch is 2.54 centimeters. Is that the way I want to write it? Is that going to work? Look at the units. Feet divided by feet, gone. Inches divided by inches, gone. What's the only unit I have left? Centimeters. That's what I want. Okay? So, all the numbers on the top you multiply, all the numbers on the bottom you divide, and that will work. 2.5 times 12 times 2.54. You can think of it as divided by 1, divided by 1, divided by 1, but that doesn't change my answer. Okay? Is 76.2. Don't forget to write the units, okay? And some of you guys, I noticed yesterday in your conversions, you weren't putting units in here. How do you know you got the right answer if you can't cancel them out and see that what you're left with is what you're asked for, right? Okay? Do it. 76.2. That's 1 dimension. Now, 2 feet. You can write all this out again, but I just did this, okay? If I multiply that by 12, and I multiply it by 2.54, then that's the same procedure, okay? That is 60.96. Don't round this, guys, okay? Because we still have to multiply these and take a difference, right? And that's going to be, my answer might be out. If it's out by 1 cubic centimeter, this answer is wrong. So not just this course, any course you guys take, don't round until your final answer, okay? Chemistry, physics, social studies, don't round till your final answer, okay? I'm kidding. All right, so how do I know the volume of box B? Length. Doesn't matter if that's the length. All I do is multiply the 3 dimensions together times, this is 2 feet by 2 feet, right? So that's the same dimension. I already have it. And what is that going to give me? This is what I have. Hopefully that's what it is. 283,168 cubic centimeters. Okay? Which box is bigger? The SI box or the Imperial box? This one. That's a bigger number. Am I done? Or do I need to do more for this question? Yeah. By how much? Okay, that one's bigger, but I didn't find out by how much. So, by how much? Well, what's 288,000 minus 283,168? 288 minus 283,168 is 4,832. And if you're good girls and boys, you'll write this in a little sentence that says, because this doesn't tell me which one's bigger, okay? I know box A, which was the metric box or the SI box, either or, is bigger by that much, okay? This is apples to apples. Now I can see which one's bigger. Okay, you wouldn't have a clue. Nobody does. I don't care who you are. Without converting it first to the same unit, you don't know which volume's bigger. Okay? Okay, this would be harder. I'm not going to do that, but I'm going to ask that in one of the assignment questions. How many sides does a box have for surface area? 6. Okay? You would need to do for that one and this one and compare it. Alrighty? 2 questions, 6 and 7. If when you get done, Make sure you do yesterday's, guys. If you can't get the surface area of a block of cheese or a Toblerone bar, that's going to be a mark you're not going to get on the test. And for sure it's going to be on there.
Are we doing the